Greetings everyone and welcome back to the bench. On the bench today we have this magnetic field power amplifier Carver M-400. So this is one of two amplifiers that were given to me. The other one is an M-400t. The guy had them, said he didn't want them, so he sent them to me. He also sent a Carver car stereo amplifier, which worked fine and is now sold. And I can't remember what he said. He said one of them might work. I don't know. It was last year and these things have just been sitting around, so I'm going to see what the deal is with them. Come with a manual. And here's some of the specs. 201 watts. They had to get that 1 watt in there, didn't they? Some of the specs there. Limited warranty. And if I remember, they had a date in the back here. Yeah, here we are. 1980. So yeah, these are 40 plus years old, I guess. So these are pretty small. I put my hand in front of it, you can see it's not very big. In the back here, you can see a row of transistors, TO3s. It's got a little switch there. It says up for mono or stereo, below 4 ohms, down for 4816. Contains a fuse. No power switch. So I guess you'd want to turn it off remotely. There is no power switch, unless it has a circuit inside that shuts it down when it detects no signal. I don't know. I don't know much about these things. But first I'm going to put it on a bulb limiter. Power it up on a bulb limiter. See if if it comes on bright, we know there might be a shorted output in there. Okay, I have it connected to a 75 watt series load, or limiter I guess you could say. And I saw it flash and go off. That was odd. Let's try that again. Flashes and goes off. So maybe it is on, it just doesn't draw a lot of power sitting idle. Okay, I'm checking for voltage on the output leads here. Jumping around. That doesn't seem too healthy. Let's try AC. There's not a lot of AC, more than I would think. Oh, there's some glare. Let's go back to there's AC plus DC mode. Yeah, there's something going on there. Same stuff on the other channel. Well, I have the bulb limiter in the circuit, and it's not a high voltage. I'm going to connect the speakers up and see what it does. Apologies for the background noise. The air conditioner is on. I don't really want to turn it off because it's really hot. So I have the speakers connected. We'll screw in the bulb here. Sounds like it's sending me some sort of Morse code. So these are kind of like that Carver PA amp I had that had 3 supply rails, a low, medium, and high. And the transistors connected to those would switch in as the signal got larger and it needed more output power. And it also has a triac that adjusts the voltage. Okay, I'm going to take a risk here with a 150 watt bulb, see what it does there. Well, it's not doing that chattering code sound, but it even lights up a 150 watt bulb, so yeah. It's not putting it out through the speakers, so that power is getting absorbed somewhere in here. Yeah, it seems pretty bright for even 150 watts. So there might be an issue with this. Okay, so I'm going to see what happens if I put some signal in here, put some music into it. Okay, we got the YouTube safe connected up here. Actually sounds good, except for that slight buzzing. But anyway, that's that amplifier. Let's take a look at the other one. Okay, so without making this video real long, cut to the chase here. And ooh, this one is a hard short. Turns the 150 watt light on fully. So yeah, I opened this one up. So this is the 400t. It's pretty dusty inside. So I'm going to have to poke around for shorted components. So it looks like this is an amplifier board, and there's one on the bottom here. And this is power supply. Doesn't look like it's fun to work on. Well, I was reading all these outer transistors to be shorted. So I took one out to measure it, and it measures fine. So then I took my flashlight and shined it through the board, and I can see that the base and emitter connectors pass through a 33 ohm. They have a 33 ohm resistor jumpered across them. So I set my meter for ohms, and yeah, I'm just measuring that resistor. Because the meter uses a small current, it makes it think it's a short. So yeah, those transistors are probably okay. Okay, I got this apart. I kept all of the screws in the baggie here. This thing is just greasy. I don't know if you can see that. Just heatsink compound everywhere. Screws are obvious where they go, so no problem getting it back together. I had to take the transformer out because the bolt on the other side of these, well, it's on the other board, but same thing. I couldn't get at the bolt. I tested every one of these transistors with the meter, both directions, all 6 ways. They are all good. according to the meter. And the voltage drops, I'm reading the forward voltage drops of the diode junctions all have about the same voltage, so probably they're okay. What else here? Oh, first bad thing I found was one of these capacitors is a dead short. That's probably the whole problem with the thing. It's hard to do this holding a camera, but was it this guy here? Hold on. Yep, this guy is a dead short. This capacitor tests just fine. Right value and everything. I have to test leakage and all that. And I probably should test all of these. They're all gooped together. That glue and stuff. So at least these aren't bad. You know, these TO3 transistors, metal cased, they're very expensive nowadays. Probably like $8 to $10 for one. But yeah, since I have it apart, I'll have to test every component. Okay, I got the wire desoldered from the board. Each one had this wire. I guess it's like a signal ground for the chassis. It goes to the chassis. And I cleaned this one up. Had a lot of dust on it. Just kind of brush it off. And use the Happy Monitor refrigerant blow-off duster thing here. I tested each diode in circuit. I know it's not foolproof, but I used the meter. Checked every diode, and there's a bunch of them on both boards. Those are good. And I went through and checked every transistor, getting values I expected. There were a couple transistors that have low value resistors connected from emitter to base or base to collector, and that will give you a short. And I checked that out. I looked on the board, made sure in both boards I was getting the same thing. So yeah, a few transistors like that. So those are probably okay. Probably really can't test that chip in circuit. Now the capacitors are another story. Most of them are bad. They need to go. So let me give you an example. I can only get a few to register on the meter. What I did is put an audio signal. I have a speaker connected with some wire here. So I can jumper across the capacitor. If I turn the music on. Okay, back again. Battery on the camcorder said no more. Okay, so I can pass the music through the capacitors on the board. Just set the volume low so you don't forward bias any silicon and you're okay. So here's an example. Stuff in the way. This capacitor says 4.7 microfarads, and this new one is a 4.7, wherever it is. There you go. Now if I put a signal through it, it'll sound kind of tinny. But I can also notice the volume of it. And if I test this capacitor, it's from here to here. Much quieter. Let's go back to this one. So I can tell this has gone high ESR. A matter of fact, most of them are like that. You know, there's some 22s. One of them's virtually open. The only good ones are these 470 microfarad 10 volt ones, but I'd probably still change them. I don't know. So I think there's 6 caps per board. So it's probably a good idea to change all of them. I imagine this board's probably going to be the same way. All the caps, all the electrolytic caps are probably shot. So I think I'm going to stop right here. We know what the problems are. I still have to test the silicon on the power supply board, and we know we have this where is it here? It's capacitor technology. This one is a dead short, and it's probably what was making that thing not work. Of course, being shorted, it's going to draw that high current and cause the bulb limiter to light up. But yeah, still got to test a lot of stuff over here. This triac seems to be okay. At least it's not shorted. I did test that. But yep, that's the first video in the repair of this thing. Okay, that'll do it. Thanks for watching.